at 2, so I have to move the class to 10 o'clock. Oh, so you have a class? Hey, how come you don't have a class today?
Today is today they cancel.
Today what?
Today they cancel, postpone.
Oh, what
Yeah.
class?
Dr. Fauzi class.
Oh, still Timber kah?
No, apa nih? TOS.
Oh, TOS 1.
Yeah.
Oh, okay. Uh,
When are you free?
hey, sorry.
When are you free for me to take? I mean, I can take earlier, maybe.
Yeah. So they prefer. So I'm thinking of shifting. So 2 weeks from now, I'm thinking of shifting the class to this time, 10 to 11:30. Let me see how.
Can I WhatsApp you?
Yeah. Okay. I you WhatsApp me later lah.
Okay, can.
Okay, let's start the class now. Right. Oh, okay. So the test. So the test is Monday. Okay. The test has been moved to Monday. It's gonna be at Magma Lukisan Serbaguna at Block B. Okay. That's where we are supposed to have our class. Okay, every week. All right. So when we start having face-to-face class, it's gonna be there as well. Magma Lukisan Serbaguna at Block B. All right. So for the test, there's only going to be one question, I think. Wait, let me, if not mistaken. Only one question, I think. Yeah, only one question. Yeah, so the test, only one question. It's going to be either parametric equation. Yeah, either parametric equation or polar coordinates. So you have to study both, but you're going to get question on one of them only. Okay. And then the formula for the identities will be given to you. So you don't have to memorize. You don't have to memorize. So I've given you this example to do. Okay, on Monday. Okay, so did you try? Have you tried? Okay. What? So what? So okay. So first question. So the first question is wait. Give me just 1 second. Check something else. Okay. So okay. So what shape did you end up with? What shape did you end up with for this question? Did you check for the symmetry? Well, so when you check for symmetry about polar axis, okay. So symmetry is it symmetrical about polar axis? So you try lah. So for it to be symmetrical about polar axis, this rule kan you have to follow. Correct? Correct. Okay, so if I try If I try a theta of pi over 4, when it's positive pi over 4, what's the answer? Berapa? What's the answer? Someone? It's 2 cos 2 theta, right? So it's 2 cos 90 degrees, right? Yeah? So what is 2 cos 90 degrees? Quick, quick, quick. Quick, quick, quick. What's 2 cos 90 degrees? Yeah. Okay. Okay, so what if it's negative pi over 4? What's the answer? It's 2 cos negative 90 degrees lah. What's the answer?
0.
So now we know this is equals to this. So therefore it's symmetrical, eh? It's symmetrical about polar axis. So what that means is, what does that mean? What it means is, whatever shape you have on top, it will get mirrored to the bottom. Okay? Next, we check symmetry. I asked you to check one. Yeah, I asked you to check symmetry. I asked you to check all three actually. I asked you to check all three. About polar, about pi over 2, and about the pole. So symmetry about the pi over 2 axis. Okay, so what this one is what? We need to check whether this is equals to this or not. Yeah, so let's try 45 degrees as well. This is equals to what? 0 kan? We did it, we've done it earlier. Okay. This one? Well, it's pi over 4 kan? So sorry. Pi over 4. Yeah. Okay, this one equals to what? What's his answer? Someone.
0.
0. Yes. Someone else, huh? Someone else next time. Someone else next time. Okay, so they are equal. Yeah, so they are equal. So it's symmetrical. About the pi over 2 axis. So what that means is, whatever shape you have on the right, it will get mirrored to the left. The same thing. Okay. So next, the one you can also check for symmetry about the pole. Okay. So symmetry about the pole. There's another set of rules that you need to check. You can check it on your own. Okay. So do this on your own. But basically, what do we know now? What do we know now? We know that whatever happens on the top, we can mirror to the bottom. Whatever happens on the right, we can mirror to the left. So what that means is actually, whatever shape you have one quadrant, you can mirror to the other 4 quadrants. That's basically what it means. Okay? That's basically what it means. Understand, guys? Faham? Because it's symmetrical. It's symmetrical about the pi over 2. It's also symmetrical about the polar axis. So what that means is you only have to find the shape between 0 degrees to 90 degrees. Then you can mirror the shape everywhere else. Faham tak? Okay, so yep. So what that means is when you do your table, theta and r, you only have to do from 0 to berapa? Okay, it's asking you for 0 to 2 pi kan? But you only have to do it to pi over 2 because then you can mirror. Okay. Yeah, so just do it. So you just have to do it to pi over 2, which is 90 degrees. Yeah. So maybe you try 22.5, maybe you try 30, maybe you try 45. Yeah. Okay. For those who have done it, what shape did you get in the end? What shape did you get in the end? For 90 degrees only, what shape did you get? 90 degrees.
Curve.
Yep, it's did you get something like this? Did you get something like that for 0 to 90 degrees?
Yes.
Yeah. Okay. So you know for one quadrant only, for 90 degrees only, you'll get this shape. So then you can mirror this shape. Okay. So obviously this is the starting point. That is IP. You go from there, down to there. Okay. So the continuation of this shape is obviously yeah, it's not like that. It's not exactly like that. It's more yeah. It's more like that. Yeah, it's more like that. Okay, so the continuation is like that, and then that one too small. Okay, I use green. Okay, like that. Then you're gonna get a shape like that, and then it's gonna do like that. Okay, that's basically the shape you're gonna get. Okay. Any questions about this one?
From me, clear.
Okay, from you, clear. Who is that?
Zulaidin, doctor.
Zulaidin, huh? Okay, thank you, Zulaidin. Thank you very much for responding. Okay. Okay, so now we are going to move into not new topic. We are going to continue on with polar, but the last section, last part of polar. Okay, so for polar, you can also do calculus of polar equation as well. Okay, so you can do a bit of calculus of polar equations as well. Okay, so what you actually use it for is it's used to look for area bounded by polar curves. Okay, it's used to, so the calculus of polar equations is used to look for area bounded by the polar curves. So what that means is like that. It's like that. So let's say okay, so let's say I have some sort of a curve, maybe like that. Okay, I have some sort of a curve like that. What I can do then is I can ask you to look for area between certain angle. So let's say I have one angle there, I have another angle there. So maybe this angle is alpha, that angle is beta. Okay, I can ask you to look for, okay, integrate for that area there. Okay. So, so the formula you use, so this area bound, this is the area bound, yeah? So to find that area, the formula is half r squared d theta. Okay, and then your limits are, you integrate from alpha to beta, yeah? Okay, so that's it. Very simple. Let's do example. Straight to example. Find the area bound by r equals to 1 plus cos theta. Okay, so find this area so obviously you have to apply this formula. However, be in a normal, so obviously this is one part of the question only. Now in tests and exams, okay, in tests and exams, I normally will not just ask you this thing. Okay, in test and exam, I'm not going to just ask you this. I will also ask you to, in test and exam, I will ask you to plot r equals to 1 plus cos theta first. Then I will ask you to find the area. Okay? So in test and exam, I will ask you more things. Okay? I will ask you about the things that you learned earlier and also the things that you learn later. I will combine into one question. Okay? So normally in test and exam, I will ask you to plot first. Then baru you find the area. Okay? So in this case, actually, before you can find the area, you have to plot. You have to plot first. Okay? So so plot this shape. Okay? So I give you the limits lah. 0 to 2 pi. Okay? From 0 to 2 pi. Okay, can you plot this for me quickly? What shape is it? Okay? So again, Okay, so let's plot first. Okay, let's plot first. How do you plot this? Still remember? How? There are two ways, right? What's the first way? What's the first way?
Long method.
Yeah, long method, right? Yeah, long method. You draw a table, theta and r. You try from 0 degrees, 22.5 degrees, 30 degrees, whatever lah, all the way to 2 pi, which is 360 degrees. Okay? You do that. Or the second method is what? The shorter, well, theoretically should be shorter lah.
Convert. Combine.
You check for symmetry first, kan?
Waduh.
Yeah, you check for symmetry first. If it's symmetrical, then you only have to plot from 0 to 180 ka or 0 to 90. Okay? So you plot. I'm not going to plot for you. This one I've done before. I've done a lot of times. Okay? I will just tell you the answer looks something like this. Okay? Once you plot, actually we've done something similar. We've done this shape before. Okay? The final answer is like that. It's the heart. Okay? It's this shape. Okay? So once you plot it, you're going to get this shape. Okay? So I want you to find the area bound by this shape. That means I want you to find all this area in there. So what's the formula? So the area bound in there. What's the formula? Quick, I just given you just now. Half. Half what?
R square d theta.
Square d theta. Yeah. And then the limits is alpha to beta. Okay. Okay. So half r squared. R squared is what? Well, you know, kan? R is this. Ini R dia. So you just square the whole thing lah. Yeah. You just square the whole thing. So half. Berapa sudah? Oh, 1. 1 plus cos theta, the whole thing squared, d theta. Okay? And then the limits is what? Well, I want you to find the whole thing, kan? The whole area. So the limits is 0 to 360 lah. Okay? So it's 0 to 360 or 2 pi. Okay? Can you integrate this? How do you integrate this? How do you integrate this? So first of all, I'm gonna take the half out. Yeah. Gonna take the half out first. Half 2 pi. 0 to 2 pi. What do you do next? What do you do next? Well, this thing is a squared gun. Okay, so you just multiply it up. So it's 1 plus 2 cos theta plus cos squared theta to theta. Okay, d theta. Okay. Everyone okay so far?
Yes.
Okay. So then it's equals to half 2 theta 0. Sorry, 2 pi 0 0. Okay. 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 Now comes to the difficult part. Integrating. The difficult part is not. So as I said before, kan, in calculus 2, the difficult part is not the things I'm teaching in calculus 2. Okay. In calculus 2 is actually, I'm teaching you this. I give you this formula. You just need to know how to use this formula. Difficult part of calculus 2 is actually calculus 1. Okay? You need to know how to integrate this. You know how to integrate this. You need to know how to integrate this. Okay? That's the difficult part. Okay. So, 1 1 can you integrate or not? So whenever you have a problem like this, you look at each variable individually. Okay, so split everything up so that everything is clear in your mind. Okay, now let ask yourself this question first, one by one. We look at each of them one by one. We look at 1, this number 1 first. Can you integrate 1 or not? Can you integrate 1 or not? Boleh kan? Why not? Who says we cannot integrate 1? What do you get if you integrate this 1?
Theta.
Alright, you get theta kan? Yeah, so you can integrate, no problem. Okay, next. So 1 okay. Okay, so 2 cos theta. 2 cos theta, can you integrate or not? Boleh kan? What do you get if you integrate 2 cos theta? Okay, cover up the 2. Cover up the 2. What do you get when you integrate cos theta? Quick. Integrate cos theta, what do you get?
Sin theta.
Yeah, sin theta. Okay, right? You integrate cos theta, you get sin theta. Okay, but you have the 2 in front. Don't forget the 2. So you put the 2. Then habis. Finish. Yeah? Okay, so 1 can be integrated. 2 cos theta also can be integrated. What about the last one? Cos squared theta. Can you integrate cos squared theta or not? Well, in its current form, cannot. Yeah? In its current form, cos squared theta cannot. So you have to change it to something. Okay? So this one, you cannot integrate straight away. You need to into a form that you can integrate. Okay, you need to change this into something that you can integrate. Yeah, cos squared theta cannot be integrated. So what form do you need to change it to? Okay, so the one that I can integrate, I copy it down first. Okay, 1 can integrate plus 2 cos theta can be integrated. Okay, plus. Okay, cos squared theta cannot be integrated, so I need to change it. Change it to what? How do you change it into something that you can integrate? The problem is the squared. The squared is there. That's why cannot integrate. So how? How do I change it into something that I can integrate? Quick, someone.
Half angle formula.
Yeah, correct. Yeah, you use your angle formulas. All right. You open up your WhatsApp. You open up your WhatsApp right now. I shared with you the formula and identities list to that. Okay, already. Yeah. You choose one from here. You choose one from here where you choose a formula from that list that has a cos squared theta. Yeah, so use this list to convert your cos squared theta into something that doesn't have a square. Which formula can you use? Cos squared theta convert into something that doesn't have a square anymore. Where? Gimana? Look at this.
Cos to theta.
1/2 1 plus cos 2 theta. Yeah, and then d theta. Okay, so we change our cos squared theta into this. So now there's no more squared. Now there's no more squared, so you can integrate easily. Okay, squared theta sudah. So now you can integrate. Okay, so now let's integrate. Not yet, not yet, not yet. We need to multiply this out first. Wait, half. Wait. Okay, 1 plus 2 cos theta. Okay, so this half bracket 1 plus cos 2 theta, we can multiply the half in. So half times 1 is half plus half cos 2 theta d theta. All right. Okay, now can you see we can simplify this a little bit? Okay. 1, I can plus the half here kan? Correct? What do you get? 1 plus half. 1 plus half, what do you get? 3/2, right? Agree?
Agree.
Okay. See, I haven't used color. I use the color. I color code it to help you. 1 plus half, you get 3/2. Yeah. That's so next you cannot do much lah. 2 cos theta and this is half cos 2 theta. Okay, you cannot do much. Okay. I thought I thought you can add the two up. I cannot. Okay, plus 2 cos theta plus cos 2 theta over 2. Okay, and then the whole thing d theta. Okay. Okay, now you can integrate. 3/2 integrate, what do you get? 3/2. 3/2 what? You get
3/2 theta.
okay. Okay, good. So 2 cos theta, just now we've done that. Okay, you integrate cos theta, you get sin theta. The 2 you just copy down. Okay, next. Okay, this one a bit tricky. Cos 2 theta over 2. What do you get? Okay, you can take the you can take the half out. Take the half out. You just integrate cos 2 theta. What do you get when you integrate cos 2 theta? What do you get when you integrate cos 2 theta? How do you integrate cos 2 theta? Cos 2 theta you integrate jadi apa?
1/2 sine 2 theta.
Sin 2 theta over 2, right?
Yes.
Okay, good. Okay. So sin 2 theta over 2. Yeah. And then don't forget your limits. Okay. Okay. Okay, so it's half 3/2 theta plus 2 sine theta plus 2 to 4. 1/4 sine 2 theta. 2 pi 0. Okay. Okay. Now, can you do the rest, guys? You just put in your limits. You just put in your limits, then you should get the final answer. Final answer is, yeah. So you can do the rest, guys. Just put the limits in. Final answer is 3/2 pi. Okay, final answer. Okay, but you need to do the rest. There's some more steps in between I didn't do for you. Make sure you do it. Any questions? Any questions?
No.
Okay, good. Okay, if there are no questions, Right, so if there are no questions, let's do another example. Or no, or rather you do it. You do it. Okay. I've got this example. Okay. Plot R squared equals to no. Yeah. 4 cos 2 theta from between angles of 0 to 2 pi. Then find the area the curve. Okay. Yep. Do this on your own. I give you 15 minutes. Okay, 15 minutes to do this. Then we meet back here at 10:55. Okay, we meet back here at 10:55. I give you 15 minutes to do it on your own. Okay. Okay, copy down the question. Do it on your own. And then I will ask someone to tell me the answer. All right. We talk about I'm sharing my screen, right? Okay. Can you still see my screen?
Can, Doctor.
So have you tried to do this? What's what is the shape like?
Butterfly.
So the shape looks like what?
Egg.
Yeah, it's like yeah, 8 figure 8, right? So you should get something like this. Wow. not wait, let me try to make it more symmetrical. Okay, something like this. IP and TP is at the same place there. So it starts IP, it goes up, it comes down, back up, like that. Can everyone get this shape or not? Everyone get this shape?
Yes.
Good. So next, so the first question done. So the second question, find the area bound. So the area bound in this case is that area there. So area bound A is what? So you have your limits. Again, it's 0 to 2 pi. Okay. You have your limits, 0 to 2 pi. And then the formula is half r squared d theta. So it's half. Okay. So watch out a little bit. So here's where you have to watch out. Pay a bit of attention. Okay. Now, if you go back to the question, my question already says r squared equals to 4 cos 2 theta. My question is already in r squared. So you just substitute the r squared straight in here. 4 cos 2 theta d theta. You don't have to square this anymore. Huh? No need to square this anymore because it's already squared in the question. Yeah. So therefore, you integrate straight away. All right, integrate straight away. Well, before I integrate, I'll yeah, I can take the 4. This 4, I can take it out first. Yeah, I take all the integers. I take all the numbers out first. Okay, 4, I take it out. 1 over 2, I'll take it out as well. So it becomes 4 over 2 on the left, on outside. 2 pi is 0 to 2 pi. Fine. So you're left with cos 2 theta d theta. Simple. So 4 divided by 2 is what? 2. 0 to 2 pi. What do you get when you integrate cos 2 theta? We've done that earlier, the previous question. So it's sine 2 theta over 2 d theta. Okay, so no more integration. Sine. So no more integration sign there. Yeah? So it's supposed to be that. Zero to 2 pi. So this 2, I can take it out again. I can take this 2 out. So it'd be 2 divided by 2 equals to 1. So literally, you're just left with sine 2 theta 2 pi 0. Okay, can you finish this up? Yeah, you can finish this out, right? Very easy. Okay, so you just substitute 2 pi in and then you substitute 0 in, you should get the final answer. Is that clear, guys?
Yeah.
Yeah, good. Okay, if that's clear, then that's good. Now, let me go through the test question quickly to see where you can answer the test question. Okay. Okay. Okay, so that's basically how you calculate the area. Okay. Next, I'm going to combine everything together. Okay. So the next example is where I combine everything together. So this is the very last example in our polar coordinates class. Next week, after test 1, we are going to jump straight into another topic altogether. Yeah, and we're going to start a new topic altogether next week. All right, vectors. Okay, so this is the very last example in polar coordinates where I am going to combine everything together. Okay, so I'm going to give you this equation, and you're going to say, oh man, that doesn't look like polar. It doesn't look like polar. What are you going to do here then? Okay, so I'm giving you this Cartesian equation now. I'm asking you to convert it to polar so that we are left with only r and theta. Then plot the curve from 0 to 2 pi. Show me the initial point, the terminal point, and direction, and then find area bound by the curve. So this is everything combined together, everything that you learn for polar coordinates combined together. Okay, so the first question is asking you to convert. Now you remember, try to cast your mind back to a few lessons ago. Kita pernah buat conversion kan? We can convert between polar and Cartesian, and then also from Cartesian to polar. Remember? Ingat kah? Let me scroll back. Let me scroll back. Okay. Will you remember these four formulas kah? Masih ingat? Yeah.
Masih.
So you can use these four formulas to convert from Cartesian to polar and vice versa, from polar back to Cartesian. Okay, so I gave you an example. Yeah, so this example, no, this is point. This is point. This is point. Mana sudah? There. There. Yeah, so this example, in this example, I give you polar. I gave you a polar. R equals to 2 sine theta. R equals to 2 sine theta. I ask you to convert to Cartesian. So that means all the r's and all the theta we want to remove and change it to x and y. Yeah. So we use those four formulas to do it. So if you can go from polar to Cartesian, that means you can also go from Cartesian to polar using those four formulas, these four formulas. Yeah, using these four formulas. Okay, try to memorize them now. Try to memorize them now. We are gonna use it. Okay. Okay. You memorized already? Okay, so let's go solve our question. Right. So how do you convert this? How do you convert this thing? So this is clearly Cartesian. How do you convert it to polar? So this is Cartesian. How do you convert it to polar? So in polar, you know r squared is equals to what?
X squared plus y squared.
Yeah. So this thing inside is equals to r squared. Actually, kan? Yeah, r squared equals to x squared plus y squared. So this is actually r squared. So you just put your r squared in there. Don't forget, there's another squared outside. Equals to 4 times x squared. X is equals to what? Tadi?
R cos.
R cos theta. Very good, thank you. The whole thing squared. And Y is equals to R.
R sin theta.
Yeah, R sin theta squared. Okay. So this is R to the power 4 equals to 4. Okay, so we just multiply it out. R squared cos squared minus R squared sin squared. That. Okay. Can I take the R squared out? I can take the R squared out then. So that I get 4R squared, right? So I end up with cos squared theta minus sin squared theta. Setuju gak?
Tujuh.
Good, thank you. Now, I have R to the power 4 here, R to the power 2 here. Can I cancel them out so that I only get R squared here? Boleh kan?
Boleh.
So that was the whole reason I took the R squared out just now. Okay, so I'm left with 4 cos squared theta sin squared theta. Okay, so I'm left with that. Okay. Now, you don't want, you cannot. So technically we finish. Sebab why we finish? Because we don't have. Technically we finish sudah. Sebab tiada x and y sudah kan? Tiada x and y sudah. We are left with only r and theta. So which is we finish converting sudah. Okay. But we don't want to leave the answer in this form. Why? Because we have squared. We have squared here. We have squared here. Once you have squared, you cannot integrate straight away. Okay. We want to remove the power 2 as well. Okay. So that later on you need to find the area. Yeah, you need to find an area. If you want to find an area, you have to integrate. If you want to integrate, you cannot integrate straight away if you have power, if you have squared there. Okay, so that's why you remove the power as well. How do you remove the power?
Identities.
Yeah, use the identities. So you find the identities, you go back to that list, you'll find the identities yourself. I'm not going to tell you which one. You look for it, but it's basically going to look like this. It's also the half angle. It's the same half angle identities that we used earlier. Okay, you're basically going to end up with this. You basically end up with this. Okay. So the half you can take out, so that becomes 2. You end up with 1 plus cos 2 theta minus 1 plus cos 2 theta. Yeah. So r squared equals to 2. 1 minus 1 equals 0. Cos 2 theta plus cos 2 theta is 2 cos 2 theta. So the answer is r squared equals to 4 cos 2 theta. There. Okay. Leave the answer like that. All right. So there, we finished converting. We finished the conversion. Next, what is the next question? Plot kan? The next question is plot, right? How do you plot it? Okay. Bukan kita suruh buat kah? R squared equals to 4 cos 2 theta. So, the previous question. R squared equals to 4 cos 2 theta. Sama kah? Sama kan?
Sama.
Yeah. So to finish the rest of this question, you just follow the previous question lah. Yeah. Okay. It's basically the same.
Okay,
Okay.
doktor.
All right. Okay. Okay. So I think we can conclude coordinates, polar coordinates here. Okay. Any questions you want to ask me? Any questions you want to ask me about the test car or about this chapter, about this topic?
Which question come out in the tests?
Yeah. I cannot tell you the exact one, but it's either polar or parametric. You have to study everything. But let me look at the test now. Wait, let me look at the test question now. Let me see how much I can tell you. All I can say is, let me double check. All I can say is, all I can say is, you study all my examples, you'll be fine. You go through all my examples, make sure you understand them, you should get full marks. Okay? You don't have to look at anything else. You don't have to look at reference book or whatever. You just understand what I taught you in class. That's enough. Just go through my notes and you'll be okay. No need reference books. Okay?
Noted.
Okay. So, minggu depan Isnin, blok B, Aras 3, Makmal Lukisan Serbaguna. All right. I booked the room already. All right. So if there are no more questions, I will see you next week face to face. So you get to see me face to face first time next week, and I get to see you as well. Yeah. Okay. Okay. I want to go for lunch. Okay. Yeah.
Attendance.
Oh, attendance. Okay. Wait. Let me unshare my screen first. Attendance. Ya, itu yang paling penting kan. Wait. Where's my attendance? Wait. Course COPO attendance. What's the date today? 19th kan? Yeah, 19th. We start at 8 o'clock, right? No, we start at 10. We started at 10 o'clock. Add slot. Share you the link. We have 66 in this class. Copy link. Okay, so All right, so in call messages. All right. So you can take a look at the chat box now. Okay, the link should be there. The link should last until 12 noon. Okay, 12 noon. So make sure you do it before 12 noon. Can you see it? Does it work? If it doesn't work, let me know.
Yeah, it worked.
It works, huh? Okay, good. All right, so I'll see you Monday. All right. Come early, because I don't know whether you've tried coming to class Monday at 8 o'clock before, but the traffic is very, very bad. So Monday class, make sure you come earlier. All right, okay. See you, everyone.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.